Hello everyone. Welcome you all to this video lecture. In this video we will discuss some expected 2-mark questions and their answers from second module of Basic Mechanical Engineering, Application of Thermodynamics. Application of Thermodynamics. Q. What is a heat engine and what are its main components? E. A heat engine is a device that converts heat energy into mechanical energy by undergoing a cyclic process. Its main components are a heat source, a working substance, and a heat sink. Q. What is an example of the application of thermodynamics in our daily life? E. An example of the application of thermodynamics in our daily life is the refrigerator. A refrigerator works by transferring heat from a cold region, inside the fridge, to a hot region, outside the fridge, using a refrigerant as the working substance. This process requires work input from an external source. Q. What is the difference between spark ignition, C, and compression ignition, T, engines? E. Spark ignition engines use a spark plug to ignite a premixed fuel-air mixture in the combustion chamber, while compression ignition engines use the high temperature and pressure of the compressed air to ignite the fuel injected into the combustion chamber. SI engines usually run on gasoline, while CI engines usually run on diesel squared. Q. What is the purpose of reheating of steam in a steam power plant? E. Reheating of steam is used to increase the efficiency and work output of a steam power plant. By reheating the steam after partial expansion in the high-pressure turbine, the average temperature of heat addition is increased and the moisture content of the steam at the low-pressure turbine is reduced. This reduces the irreversibilities and losses in the cycle. Q. What are the advantages of using a multi-stage air compressor over a single-stage air compressor? E. A multi-stage air compressor has several advantages over a single-stage air compressor, such as it can achieve higher pressure ratios with lower work input and higher efficiency. It can reduce the temperature rise and intercooling requirement of the air during compression. It can improve the volumetric efficiency and reduce the leakage losses of the air. It can reduce the size and weight of the compressor for a given output to the power of 4. Q. What are the main components of a refrigeration system and what are their functions? E. A refrigeration system consists of 4 main components: a compressor, a condenser, an expansion valve, and an evaporator. Their functions are as follows. The compressor compresses the low-pressure refrigerant vapor from the evaporator and raises its pressure and temperature. The condenser rejects heat from the high-pressure refrigerant vapor to the surroundings and condenses it into liquid. The expansion valve reduces the pressure and temperature of the high-pressure refrigerant liquid and throttles it into the evaporator. The evaporator absorbs heat from the low-temperature medium to be cooled and vaporizes the low-pressure refrigerant liquid into vapor. Question. What is the difference between a heat pump and a refrigerator? Answer. The difference between a heat pump and a refrigerator is that a heat pump is a device that transfers heat from a low-temperature source to a high-temperature sink, while a refrigerator is a device that transfers heat from a high-temperature source to a low-temperature sink. The desired effect of a heat pump is to provide heating, while the desired effect of a refrigerator is to provide cooling. Question. What is the coefficient of performance, COP, of a heat pump? Answer. The coefficient of performance, COP, of a heat pump is the ratio of the heat delivered to the high-temperature sink to the work input required to operate the heat pump. It is given by the formula, where QH is the heat delivered to the high-temperature sink and W is the work input. Question. What is the COP of a Carnot refrigerator operating between 0 degrees Celsius and 30 degrees Celsius? Answer. The COP of a Carnot refrigerator operating between 0 degrees Celsius and 30 degrees Celsius is given by the formula, where TH and TL are the absolute temperatures of the high temperature and low temperature reservoirs, respectively. Substituting TH equals 303 K and TL equals 273 K, we get. Question. What is the difference between a heat engine, a refrigerator, and a heat pump? Answer. The difference between a heat engine, a refrigerator, and a heat pump is that a heat engine converts heat into work, while a refrigerator and a heat pump transfer heat from one place to another. A heat engine operates between two reservoirs at different temperatures and produces work as output, while rejecting some heat to the low-temperature reservoir. A refrigerator operates between two reservoirs at different temperatures and consumes work as input, while extracting some heat from the low-temperature reservoir and rejecting it to the high-temperature reservoir. A heat pump operates between two reservoirs at different temperatures and consumes work as input, while extracting some heat from the low-temperature reservoir and delivering it to the high-temperature reservoir. Question. What is the difference between a vapor compression refrigeration cycle and a vapor absorption refrigeration cycle? Answer. The difference between a vapor compression refrigeration cycle and a vapor absorption refrigeration cycle is that in a vapor compression cycle, the refrigerant is compressed by a mechanical compressor, while in a vapor absorption cycle, the refrigerant is absorbed by a liquid solution and then pumped to a higher pressure. A vapor compression cycle consists of four processes: compression, condensation, expansion, and evaporation. A vapor absorption cycle consists of four processes: absorption, pumping, desorption, and expansion. Question. What is the function of a boiler in a steam power plant? Answer. A boiler is a device that converts water into steam by heating it at constant pressure by an external heat source. The steam produced is used to drive the turbine and generate electricity. Question. What is the function of a turbine in a steam power plant? Answer. A turbine is a device that converts the kinetic energy of the steam into mechanical energy by expanding it through a series of blades. The mechanical energy is then transferred to a generator to produce electricity. Question. What is the function of a condenser in a steam power plant? Answer. A condenser is a device that cools and condenses the exhaust steam from the turbine at constant pressure and temperature. The condensed steam, also known as condensate, is then pumped back to the boiler to complete the cycle. Question. What is the function of a pump in a steam power plant? Answer. A pump is a device that increases the pressure of the condensate by supplying mechanical work to it. The high-pressure condensate is then fed back to the boiler to be heated again. Question. What are the advantages of using superheated steam in a steam power plant? Answer. Superheated steam is steam that is heated above its saturation temperature at a given pressure. The advantages of using superheated steam are: it increases the thermal efficiency of the cycle by reducing the moisture content of the steam. It reduces the erosion and corrosion of the turbine blades by avoiding wet steam. It increases the power output of the turbine by increasing the enthalpy drop across it. Question. Are the disadvantages of using superheated steam in a steam power plant? Superheated steam also has some disadvantages, such as: it requires more heat input to the boiler, which increases the fuel consumption and cost. It requires more complex and expensive design of the boiler and turbine, which increases the capital and maintenance cost. It increases the temperature and stress of the turbine blades, which reduces their lifespan and reliability. Question. What are the types of boilers used in a steam power plant? The types of boilers used in a steam power plant are: fire tube boilers. These are boilers where the hot gases from combustion pass through tubes surrounded by water. The heat transfer from the gases to the water is mainly by convection. These boilers are suitable for low pressure and low capacity applications. Water tube boilers. These are boilers where water flows through tubes surrounded by hot gases from combustion. The heat transfer from the gases to the water is mainly by radiation. These boilers are suitable for high pressure and high capacity applications. Question. What are the methods of improving the efficiency of a steam power plant? The methods of improving the efficiency of a steam power plant are: increasing the boiler pressure and temperature. which increases the enthalpy of the steam and reduces its specific volume. Increasing the degree of superheat, which reduces the moisture content of the steam and increases its enthalpy. Increasing the condenser pressure, which reduces the heat rejection and increases the work output. Using regenerative feedwater heating, which reduces the heat input to the boiler and increases its temperature. Using reheat cycle, which increases the average temperature of heat addition and reduces moisture content of exhaust steam. Thank you all for watching the video. Keep preparing. If you have got any doubt, write it on the comment box. I will be happy to answer them. All the best.